Today we're going to talk about adding and subtracting fractions. We'll start off with adding and subtracting fractions with the same denominator, and then we'll end up talking about adding and subtracting fractions without the same denominator. We say with unlike denominators. Tomorrow we'll move on to adding and subtracting mixed numbers with no regrouping, and then we'll move on to adding and subtracting fractions with regrouping and whole numbers to finish up the lesson. So let's go ahead and take a look. I don't know how much background knowledge you have, but let's go ahead and take a look. We're going to start off with looking at fractions strips. Make sure you take notes on notebook paper for this video, okay, and keep it in your binder. So if you look at number one says you have 5/8 plus 2/8. All right, so what I'm going to do is highlight what I have, just showing fraction strips. And you may already know this. If you do, that's fine, but make sure you're paying attention because I'm going to change it up. Right now, I'm just doing just the basics, what you should already know. So I'm going to highlight that's 1/8, 2/8, 3/8, 4/8, and 5/8. And what I want to do is add 2 more 8s to it. So if I add 2 more 8s to it, let's add 2 more and see how much I have in all. Well, I can clearly tell if I have 1, 2, 3, 4, 5, 6, 7, 8s. So this is just to show you that you never add the denominators. I've seen some people add the denominators. We don't do that. So all you do is add your numerators when the denominators are the same, and you keep the denominator. So 5 plus 2 is 7, and you keep your denominator. Again, we don't ever, let me fix that. We don't ever change the denominator by adding them or subtracting them, as I've seen some students do. So that equals 7/8, guys. All right, next, I'm going to take a look at 5/6 minus 1/6. Let's do the highlighter. So I'm going to start out with, I'll make this a little thicker. 1/6, but I need 5/6 to start off with. 2/6, 3/6, 4/6, and 5/6, okay? But instead of adding a 6, I want to take away a 6. So I'm just going to take away a 6. In other words, what I had highlighted here, I just take it back. So that puts it, I need the pen. That's 1, 2, 3, 4, 6. And I don't know if you all know much about simplification. If you don't, I'm going to need you to pause the video and tell me. Okay. But I'm going to go ahead and simplify, because you're going to write an equivalent fraction just in simplest form. You can divide both 4 and 6 by 2. And 4 divided by 2 is 2. 6 divided by 2 is 3. So 4/6 simplifies to 2/3. The answer is 2/3 for that one. If this is not something you're familiar with, pause the video and tell me if you're not familiar with simplification, and I'm going to help you with that, okay? Because you're going to need to know that. And let's take a look at this one. But again, just to reiterate right here, you do not add or subtract your denominators. Once your denominators are the same, you keep it. Okay, let's take a look at the last one, 3/4 plus 2/4. All right, so I have, make that thicker, 1/4, 2/4, which is a half, and 3/4. But then I'm going to add to it another 2/4. Add to another 2/4. So I'm going to add another fourth which makes 1, adding 1 more fourth, and add the second fourth. So now I have 3 fourths plus 2 fourths, which makes a total of 5 fourths. So this is 5 fourths. But this is called an improper fraction. And we don't want to leave fractions in terms of being improper, okay? An improper fraction is when your numerator is larger than your denominator. When your numerator is larger than your denominator, you need to see how many wholes you can get out of it. Like how many whole pieces, how many whole strips. Here, this is 1 whole strip, or it's 4 fourths, which is 1. And then another fourth left over. So 5 fourths is the same as 1 and 1 fourth. 1 whole, you get a whole group of 4 out of it, a fourth out of it. And then 1 fourth left over. Now, if you don't have fraction strips, I'm going to show you how to get 1 and 1 fourth without looking at fraction strips, okay? So I'm going to have to erase something so I have more room. All right, so what you're going to do is you're going to divide and write it as a mixed number. It's called a mixed number. So we're going to divide, and I call it T-bow. T-bow for put the top in, what's on my inside of the house, and the bottom out. Okay? So I'm going to put 5 in the house and 4 outside. And say, how many groups of 4 can I get out of 5? Well, that would be 1. And 4 times 1 is 4, so I subtract 4. And I have 1 remaining. So we don't do 1 remainder of 1. I've seen students do that coming from elementary school. 1 remainder of 1. We don't do that in 7th grade math, and once we go on to 8th or what have you. That's just elementary, so we never do that. So what you do is you write this as a mixed number. This becomes your whole number. They call this the quotient. The number at the top is your whole number. Your remainder is your numerator. And your denominator never changes. So my denominator was 4 here. It's still 4. Okay? So, of course, 1 is your whole number. There's 1. 1 is your numerator. That remainder is your numerator. And 4, what you're dividing by, is your denominator. That's how you change an improper fraction to a mixed number. Let me see if it'll reset. There we go. Let me go on to the next page. Okay, so that's when you have just regular addition, subtraction, and fractions. Now I'm going to throw in some signs, guys, okay? I'm trying to see if I make the screen bigger, but it's not coming up. Oh, there we go. All right, so now I'm going to take negative 5/8, and because I don't have any negative fraction strips, what I'm going to have to do is color code these. So if I color code it yellow, it's going to be positive. If I color code it blue, it's going to be negative, okay? So I'm going to have to use different colors for these. All right, so negative 5/8. And it's going to be in yellow. Oh, excuse me, blue. That's 1, 2, 3, 4, 5, guys. And then I have positive 2 eighths. So that's going to be in yellow. You have 2 of those. All right, so what you do is you look and see if anything cancels. Or can you pair anything together to make 0? And there are some things we can pair together. Negative, this is red. Think of this as negative. Think of these as negative. And these are positives. You can take this negative 1/8 and put it with that positive 1/8, and they cancel each other out. You can take this negative 1/8 and put it with that positive 1/8, and they cancel each other out. And I'm left with negative 3/8. Okay? Okay, let's look at the 6. I have negative 5/6 minus 1/6. All right, I'm going to model that. Negative 5/6. And I said negatives will be in terms of, they'll be blue, in the color blue, okay? Okay, there are my 6. I'm going to pull them up. So let's make those blue. And again, you can see on these, although I put in negatives, the denominators are not changing when they're the same, okay? I still had an 8 and a negative 3/8 for that first one. So let's go ahead and highlight negative 5/6. 1/6, 2/6, 3/6, 4/6, and 5/6, guys. Hold on. I need the pen. Okay. Negative 5/6. Now, just to show you what color this next one will be, because I know somebody's confused on whether it's going to be positive or negative. I'm going to rewrite this. This is negative 5/6, and minus 1/6 is the same as plus negative 1/6. And you should have learned that in the video with where I told you that, say for instance, it started off at 5 degrees and then it dropped 2 degrees. So if it starts off at 5 and drops 2, you could do 5 minus 2, or you could do 5 plus negative 2, okay? So minus a positive is the same as plus a negative. So I'm going to go ahead and add another negative. And so we end up with negative 6/6. But notice that this whole thing is shaded. So even when you have the same numerator and denominator, I need you to fix it. Not just when the numerator is higher than your denominator or improper, when your fraction is improper. But when the numerator and denominator are the same, go ahead and write it as a whole. But in this case, it is negative 1. Okay? All right, let's take a look at the last one. And I need to go ahead and put these answers back, because we're going to talk about what we do without fraction strips in just a minute. All right, so when I put those back, I'm going to take a look at 3/4 plus negative 1/4. Okay, so here we go. 3/4 is positive. Positive again was yellow. Okay, so positive 3/4. Let me make that bigger so it won't take so long. 1/4 2/4, 3/4. And then the negative was a full. So here you have a negative 1/4. So I'm going to change the color and put negative 1/4. But now in this case, I can put, and this is negative, I can put this positive 1/4 with this negative 1/4, and they make 0. In other words, they cancel each other out. So I can see that I'm left with 2/4, or half of the fraction strip. This whole thing right here that I circle represents half, because this is 2 out of the 4. So this simplifies to half. Or you could just say both of these are divisible by 2. But the main thing you want to take away from this is that when you add or subtract fractions, whether they have positives, all positives, or you have positives and negatives, when you add or subtract fractions that have the same denominator, you never, ever, ever add your denominators. You keep it. You also want to remember that when you have an improper fraction, you change it to a mixed number. Or if you have the same numerator as the denominator, that you change it to a whole number, okay? It's some whole number, the whole number 1 or negative 1. All right, guys, I want to point something out with these, with this particular page. I'm going to take a look at direction right now, okay? That's for this particular page. So if I think about same direction, add, different direction, subtract, because that's what we do with positives and negatives. Let's take a look at what we have. So I'm going back to this. This was negative 5/8 plus 2/8. With a negative number, and only focus on the numerator, guys, because the 8s are the same. So look at negative 5 plus 2. Okay, so if I focus on negative 5, that will be going to the left 5. And I focus on plus 2, that would be going to the right 2. Well, what do you do if it's left 5 and right 2? Well, that would be not same direction, but different direction. You would subtract. So if I subtract, I get 3/8. But it's more to the left than it is to the right, so that makes it negative. Okay, let's take a look at this other one. So I have negative 5/6. And I know the negative is with the bar right here, okay? But I normally go back and always write it with my numerator, okay? Negative 5/6 minus 1/6. And if I think about direction, just for my numerators, because my denominators are 6, that would be left 5, and this would be left 1. Well, these don't go in different directions. They go in the same direction. So I would add 5 plus 1 is 6. Keep your denominator. And they're both to the left. So it has no choice but to be negative. That's how we get negative 1. So you don't need to use fraction strips. You can just use your integer rules that you learned for addition and subtraction, okay? Let's take a look at the last one. I'm going to have to erase some of this. If you don't have it, make sure you pause it or rewind it, because I erased something already, and write it down. Okay, so if we take a look at 3/4 plus negative 1/4. Usually when you add a negative, you have it in parentheses, guys. So that's my fault. Let's go back and do that. Or subtract the negative, it goes in parentheses. So this is going to be right 3. And this is going to be left 1. But they don't go in the same directions. They go in different directions. So you subtract 3 minus 1 is 2. And it's more to the right than it is to the left, so it's positive. But 2/4 is the same as 1/2. So again, this just goes to show that all you have to use are your integer rules that you learn for addition and subtraction to add or subtract fractions with the same denominator, although they have positives and negatives. All right, let's talk about what we do if they don't have the same denominator, okay? I keep trying to make the screen bigger by looking for the increase icon at the bottom, but let me see if I can make it bigger this way. Hold on. There we go. Okay, that's much better. All right, so what do we do if our denominators are not the same? And I hope you know this because this should be a review from elementary school. If you don't worry about it. I'm going to cover it in this video. I'm about to tell you right now. So it says take 2/3. That's 1/3 and 2/3. And I'm not labeling these as positive or negative. These are both all positives, okay? 2/3, and you're going to add it to 5/6. Well, I'm going to do a different color for the bottom. 5/6. That's 1/6, 2/6, 3/6, 4/6, and 5/6. Well, you definitely can't add thirds to 6. It doesn't make any sense the way it is. Because as you can see, a 6 is so much smaller than a third. So a 6, that's what a 6 looks like. This is what a third looks like. A third is so much larger. The 6 is so much smaller. Okay? So we can't add those pieces together. They're not the same. So what do I do? All right. So this is what I need to do. I can't erase those because I erased this whole thing. But that's bothering me. Y'all hold on. Since a 6 is not the same as a third, the question is, what do I do? So let me fix this. Okay. So I am going to see if I can get the third to be broken down into 6. Can I get the larger larger part to be broken down into the smaller part? Because normally that's what we can do. We can see if the larger part can be broken down into smaller pieces. So I'm just going to slide this down and put it over that. Let's see. That's not what I'm trying to show you. If I move it, I don't think it's going to work. Hold on. No, it's not allowing me to move the whole thing. Let me see if I can lock it and then move it. Nope. All right, so you're going to have to imagine that this overlaps, okay? So you're going to have to imagine that this piece right here, this third, can make how many of these 6s? So I'm trying to get you to tell how many of these 6s fit into one of these thirds. Here's 1/3. 1/3 is right here. That little section right there. From there to there. How many of these 6s would fit into that third? That 1/3 right there. Well, as you can see, it takes 2 of those 6s to make 1/3. Okay. So how many 6s would fit into, let me do the other third. Here's the other third. There's a third. But how many of these 6s would fit into this third? That's over here in red. Well, 1, 2. So in the whole 2/3, this is the whole entire 2/3 right here. How many 6s fit into the entire 2/3? Well, you should be able to tell 1, 2, 3, 4. 4 of those 6s fit into the entire 2/3. Normally, if I had this on Smart Notebook, I could just move the highlighted part, and the fraction strip, and one sits on top of the other one. And it's just it's easy to see. Okay? So, let me move this back. Since the pieces are the same now, guys, you can go ahead and add them, okay? I am going to slide this back down and set this up where it looks much better, because it did not look good to me. So we found out that there were, let me go ahead and highlight these. It was 5 of these 6s. We found out that inside of this third was 2 6s. And inside of this third would also fit 2 6s. So inside of the whole 2/3, it's 1, 2, 3, 4 6s. Okay? But we still had to add 5 more 6s to it, which makes a total of 9 6s, or 9/6. So this is what we call, again, an improper fraction, because the numerator is higher than your denominator. So I'm just going to put that in the house and that outside of the house. Top in, bottom out. I'm going to T-bow again. All right. How many 6 can you get out of 9? 1. And you subtract, you get a remainder of 3. But remember, in this class, we don't do remainders. The remainder becomes our numerator. So 1 quotient, this is our quotient, becomes the whole number, and then 3 6. And you can divide both of these by 3 to simplify. 3 out of 6 is the same as 1/2. So 4 2/3 plus 5 6 is the same as 1 1/2. And you can also see the picture. You got 1, 2, 3, 4, 5, 6. 6 6 will make a whole, and it's 1, 2, 3, 6 left over. Okay, so if you don't have fraction strips, what do you do? Because I know you're not going to be drawing fraction strips this whole time. So let me show you what to do if you don't have fraction strips, if you don't already know. The key is to get the pieces the same. So when I say pieces the same, I mean your denominators, because I want the same denominators. I don't want thirds and 6. I want 6 and 6, or thirds and thirds, okay? So what you do is you list a least common multiple, LCM. So I'm going to do what we call a T-chart to help organize our work. So I put like a T. There's my T, and the top part of the T I put my 3, and the other part of the T I put my 6. So I put my denominators in my T, and then I just start listing multiples of my denominator. And I can already tell before I keep listing anymore that 6 is a common denominator. So we got to find a common denominator. Well, 6 is a common multiple, so 6 can be a common denominator. So what you would do, excuse me, guys, what you would do is make sure that both were in terms of 6. Okay, well, 2/3 is definitely not in terms of 6, but 5 6 is. So what you do to put 2/3 in terms of 6 is you multiply that fraction, that whole fraction, meaning the numerator and denominator, by some number that will make it where the denominator is 6. It's kind of like scaling it up. So you're going to multiply both. But what could you multiply thirds by? Your denominator, to make a 6. Well, 3 times 2 is 6. But you're multiplying the entire fraction. So don't just do 3 times 2. What you do to your denominator, also do to your numerator. So an equivalent fraction for 2/3, if I multiply both numerator and denominator by 2, would be 4 6. It just has a different name, but it's the same fraction. It's still 2/3. This is 1/3. That is 2/3. But written in terms of 6, it is 4/6. Okay. I'm not going to worry about this one because the denominator is already in terms of 6. So you just bring it back down. So we end up with 9/6 or 1 1/2 when we simplify. I'm not going to go through the division process again. Okay, let's take a look at some more. And then we'll get into negatives, guys. All this is review. It should be. Please move up. Okay, I have to do it that way. All right, so I have some space. Let me get these out of the way. All right, so I have 3/4 plus 1/6. It says try these. You can pause the video and see if you can do those on your own. I'm not going to worry about the mixed number. I just saw that. We're not going to worry about the mixed number right now. I definitely don't want the highlighter. All right, so I'm going to make my T-chart and list my least common multiple. There's my T. I put my denominators in the top of the T, and I start listing multiples of 4, 4, 8, 12. And if you know the least common multiple, then go ahead and write it. You don't have to do the T-chart. So 12 is my least common multiple. So neither of these are in terms of 12s. One is in terms of fourths, or has a denominator 4, and the other has a denominator of 6. So let's fix that. So I'm going to write this bigger, guys. I'm going to multiply both numerator and denominator by something. Start off with what would you have to multiply 4 by to get it in terms of 12s? Well, times 3. So multiply both numerator and denominator by 3. That would give us 9/12. What would you have to multiply 6 by to make 12? 2. But multiply both numerator and denominator by that, so that's plus 2/12. Now they're both in terms of 12s. They have the same pieces. They're the same parts. So 9/12 plus 2/12 is 11/12. Not going to worry about the mixed number right now. It's not something I'm going to ask you to do. But I think what I want to do is go ahead and show it to you. You won't have this for homework, though. But I'm going to go ahead and show this to you. Here you have 9 and 5, 6, and 4 and 1, 8. I am going to make my T-chart and list my least common multiple. You basically treat it the same way. You're going to put your denominator of 6 and the denominator of 8. So we have 6, 12, 18, 24, 30, just list a few. If you don't find one soon, you just keep listing. 8, 16, 24. 24 is a common multiple. And what I'm going to do is multiply both of these by the same number. So what can you multiply 6 by in order to get that 24? Well, 6 times 4 is 24. So you need to multiply both the numerator and denominator by 4. Keep your whole number 9. So please don't multiply the whole number by 4. Just numerator and denominator, guys. So that would be 20. 9 and 20 over 24. Minus, okay. What am I going to multiply these by? The numerator and denominator. Well, what do you multiply 8 by to get a 24? 3. So you multiply both by 3. So that's going to be minus 4 and then 3 24s. When you have a mixed number, you can simply go ahead and subtract once your denominator is the same, subtract your numerator from your numerator. 20 minus 3 is 17. You know, once we have the same parts of the same denominator, we keep it. And then, of course, 9 minus 4 is 5. And that's all you do for a mixed number. Now, some teachers will tell you to change your mixed numbers to improper fractions and then find the common denominator and then add or subtract the numerators. I don't like that because the problem gets so big. When you change your mixed number to an improper fraction, your numerator can be unusually large. But if that's the way you've been taught and you prefer to keep it that way, I'm fine as long as your process is right. But I never teach mine that way. I always leave my whole numbers alone. I don't change anything to a mixed number. So I never get rid of my whole numbers when I'm adding and subtracting fractions. I leave them as mixed numbers. All right, let's take a look at some that have signs and also don't have the same denominator. So now you're going to have to apply your integer rules and use the T-chart or find a least common multiple because these parts are not the same. All right, so let's take a look. I'm going to use the T-chart first of all because we cannot add and subtract pieces that are not the same. So my denominator for one fraction is 8 and for the other is 3. So I just start listing multiples until I find a common one. Ooh, I'm going to have to list for a while because 3 is a small number. Still nothing. Okay, 24 is the common multiple, the least common multiple. All right, so I'm going to multiply 8 by 3, which means I'm multiplying 7 by 3. And that will give me negative 21 24s. Again, I usually take this negative and put it with my numerator. All right, now what do I multiply 3 by and 2 by here? Well, 3 times what gives me 24? 3 times 8 gives me 24. So that's going to be plus 16 over 24. All right, now I just need to establish direction. That's left 21. Look at your numerators once you get your pieces the same. And right 16. Well, those go in not the same direction, but they go in different directions. So I'm going to subtract. 21 minus 16 is 5. And it's more to the left, so it's negative 5/24. Now, is it okay if you put your negative with the fraction bar or your division bar? Sure, I don't care. You can also put the negative with the 24. I don't care about that either. Just don't put it with both the numerator and denominator. All right, let's do a T-chart for the next one. We have 8s and 4s. 8, 16. So here we have 4, 8. I know I can stop, but I'm going to show you something. It doesn't matter if you use the 8 or you use the 16. If you use the 8, you'll do less simplification. If you use the 16, you're going to have to simplify. All right, notice this one is already in terms of 8, so I'm just going to bring it down. And I take this negative, and I always write it with my numerator, guys. Okay? And then what do I multiply 4 by to get 8? Well, I multiply 4 by 2. It's always, what do you multiply your denominator by? Once you figure that out, that's what you multiply your numerator by, okay? So that's going to be minus 2 8s. Now you just establish direction. So this would be to the left 3. And minus 2 would be to the left 2. So they go in the same direction. So you're going to add. That will give you 5 8s. But they're both to the left. So it's negative. All right. You're going to pause the video and you're going to try all 3 of these on your own. And then you'll unpause it to check it. And this is the last thing you'll do before homework, okay? Okay, this is what you should have gotten. I'm going to do a T-chart of 6 and 4s. 6, 12, 18, 24. Here you have 4, 8, and as you can see, 12 is the least common multiple. So I'm going to write this bigger because I don't like it being so small. So what do you multiply 6 by to get a 12? Well, 6 times 2 is 12. So you got to multiply your 5. You're a negative 5 times 2. Keep in mind, I take this negative and put it with the numerator. So that'll be negative 10 12ths. And then I say, well, what do I multiply 4 by to get a 12? 4 times 3 is 12. 3 times 3 is 9. Okay, so I have minus 9 twelfths. Now, once your pieces are the same, you can establish direction, guys. So this is left 10, and this is left 9. So they go in the same direction. So I'm going to add them. That would have been negative 19 twelfths, but that's improper, guys. I know it's negative, by the way, because they both go to the left. It's also improper, so I'm going to divide to change it to a mixed number. We talked about that. How many groups of 12 can you get out of 19? Only one. Subtract 12. So that's 1. Actually, it's going to be negative 1. And 7 twelfths. Negative 1 and 7 twelfths is what you should have gotten for that one. Okay, let's take a look at the second one. You have 9 fifths. No, you have 2 ninths and negative plus negative 1/5, so you have ninths and fifths. Now, if you didn't have to use a T-chart, that's fine with me. I am absolutely fine with that, not 9, 10. It's 4 o'clock in the morning while I'm making this video, so I'm a little tired. All right, 9, 18, 27, 36, 45. Then here, if you skip count, you still nothing, still nothing, still nothing. But of course, you can tell when we get to 45, we're good. So I'm going to rename these by making an equivalent fraction. What can you multiply 9 by to get 45? Well, that would be 5. So that would give me 10 45ths. And what do you multiply 5 by to get 45? Well, that would be a 9. So that would be plus, and you bring the signs down, guys, plus negative 9 45ths. Don't ever change the signs up. Don't change the plus up or the negative in front of it. The signs stay the same unless it's a double negative. If it's a double negative, I'll allow you to go ahead and rewrite it as a plus, okay? All right, so here, what I mean by double negative, suppose this one right here was written as negative 7/8 minus negative 3/10. I'm looking at this one. I would let you change this minus a negative to plus 3/10, okay? That I would allow you to do. Other than that, don't change the signs, okay? Now let's go back to this other problem. This is to the right 10, and this is to the left 9. So they go in different directions, so I'm going to subtract. That's 1 45th, and it's positive because it's more to the right than it is to the left. Okay, let's take a look at the last one. Now keep in mind, I did say you could change up one set of signs. If you see minus a negative, it's the same as negative 7/8, for instance, in this case, plus 3/10. I will allow you to fix those. Those are the only ones I want you changing the signs on, okay? All right, so I have 8s and 10s go in my T-chart. 8, 16, 24, 32, 40, and I can already tell you it's 40. All right, so 8 times what gives me 40? 8 times 5. That would be negative 35 40ths. And 10 times what gives me 40? 10 times 4. So multiply both numerator and denominator by 4. That will give me 12 40ths. Now, since the pieces are the same, I can establish direction. This is to the left 35, and this is to the right 12. Since they go in different directions, I'm going to subtract. So 35 minus 12 is 23, but it's more to the left. So you make it negative 23 and keep your same denominator once they're the same. Negative 23/40. All right, guys, that's all I'm going to do for today. Tomorrow I'll go over mixed numbers, but I need you to go ahead and start on your homework, okay? Thank you.